Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at encapsulation before we move on to look at more inheritance. So I'll declare a little class up here to demonstrate this in Eclipse. Let's create a class called frog. And we've seen that it's very common to give our classes private instance variables. So let's give this a private string name. And let's give it some public methods as well. Well, let's have a constructor that sets the name so that in our main function here, we'll be able to do stuff like frog, Freddy. So when you do this, you're implicitly calling the constructor. So this isn't going to work at the moment. But because we're implicitly calling a constructor when we construct the object, and because we're calling this constructor from outside the class, the constructor will have to be public. So let's say here, frog string name, and let's use the initialization list to initialize name with whatever's passed in, and we'll provide a dummy implementation to make the compiler happy. So this is kind of an example of encapsulation at work. Encapsulation means that we hide away the instance variables, and we only provide some public methods that are going to be documented, which the user of the class, which may be yourself, is going to call in order to do stuff with the class. So we declare the methods public. That means we can call them outside of the class, like this constructor is being called implicitly. And we encapsulate all the instance variables, hide them away so no one can mess with them. If we didn't do that, we could end up with a bunch of different objects that are all setting each other's instance data. And what would end up with would be likely a kind of tangled rat's nest of different objects all directly accessing each other's data, which makes for very hard to maintain, difficult to read code. And that's why we restrict as much as possible access to the class and just have these publicly documented methods that we allow the user to use to do things with the class. So we could have another example here. Let's have a public string get name, and let's just return name in there. So again, we're making it public, and if we write up documentation for this class, we document that get name exists and that it's a public method. Let's say here frog.getName, and let's just check that this works, because I'm never completely sure until it's actually built and running, and ideally tested quite thoroughly as well. So we've got Freddy there. Now it's common to have methods in your object that we require some other method to make them work. So you might have some kind of method. Let's say it's a public method in your object, which needs some other block of reusable code in order to do its thing. But so that block of reusable code is going to go in a method in the class, but we don't want users to be able to do stuff with that method. So just to give you an example here, let's say here that we've got a frog void. Let's call it info. And info is, just to take a really simple, kind of slightly too simple example, let's say that info outputs information about the frog, my name is. And let's say we've decided that the end user of this class shouldn't ever need get name for some reason, but they do need info. Then we can call get name here if we need it. And of course, in this simple example, we could just put name there directly. You can just, of course, you can refer directly to instance variables within the methods of your class. But imagine that something more complicated is going on here, and this info needs to have some method containing some reusable block of code, like getName. But imagine that we don't want to make getName public. We can actually make getName private. So let's say here cout, well, not cout anymore, but let's say frog.info. Let's check that this works. So I'll just save it and run it. And it says my name is Freddie. But now the idea behind encapsulation is, besides hiding away your instance variables, you want to also make private absolutely anything that you can, including functions. So if we don't need the user to call getName outside of the class, we can put this in the private section up here. So this still works. Info can happily call getName even though it's private, because getName is part of the class, and private means that only the class can use this stuff directly. So within these brackets of the class, our methods can call private methods and can access private data. But now that we've made getName private, we can't do stuff like frog.getName here outside of the class. Let's just prove that. So I'm going to build this, and we see that we've got an error. And again, this is encapsulation at work. You should make anything that you can, whether it's data or functions, make it private. Make as much of your class private as you possibly can. Encapsulate it within the class. Hide it away from the end user in order to reduce the possibility of the user of the class, even if that's yourself, creating some sort of tangled rat's nest. If the end user doesn't need this, make it private if it's only needed within your class. And a common thing to do is to declare your private methods in a separate private section to the instance data, just so that visually you're not mixing up a load of methods with instance data. So you can have as many of these public and private sections as you want in whatever order you like. And a common order is that you declare the instance data private at the top first. And then you might have a section with private methods, and at the end you might have public methods. But that's not the only order, because some programmers reason that the public methods should be declared at the top, so that the user of the class sees those if they look at the class definition here. And then the private data, which after all is hidden away, is placed at the bottom because you don't want to draw people's attention to that. But I like this form, which I think is more common, where you declare your private data at the top, and any public methods are going to follow that, and probably your private methods, they're probably going to go after the data. But it's a question of whatever you feel is most legible, really, the order of these private public sections. So we don't need to repeat this key word. The only reason I've done it is to visually put the private methods in a separate section to the private instance data, just to make this easier to understand what's going on. So I think that's all I'm going to say about encapsulation here. And the end message is just make anything private that you can in your class. So if you want to practice this, try creating a class with some private data and private methods, and try calling those private methods within your public methods. Remember that the public ones are the only ones that you would document for the end user. They're the only ones that the end user can call, and everything else is private. And you can also experiment with, having private and public sections in different orders if you want. Have a go at that and just check that you understand the syntax here. But it's pretty simple, and we've seen a lot of it before. So hopefully that won't give you too much of a headache. So that's it for this tutorial, and until next time, happy coding.